Welcome everybody. Today we will be doing AP Calculus. So this is the previous question paper, that is 2023. Now the first question is using the correct units. However, I will display the question on the board here. You can read the question, but I will be evaluating the sections part by part. So the first part one says use the correct units, interpret the meaning of integral 60 to 135 f of t dt in the context of the problem. Now, in the context of the problem, this is the solution you need to write, right? The integral, the limits are from 60 to 135, f of t dt represents, this is a keyword, the total amount of gasoline that is being pumped into the tank from 60 seconds, this unit you need to place, to 135 seconds. So this is the first part, and if you were to provide this, you will get 1 mark. Now let's move on to the next one. Now this is the second part. Use Wright-Raymond's sum with 3 subintervals 60 to 90, 90 to 120, 120 to 135 to approximate this value. Now first you need to write the Raymond's sum. So this is the solution. So you can start like this. We know that integral 60 to 135 f of t times dt, you can use the approximation, and we have to actually place each of these subintervals. So you place the first value, so that's larger value is 90, so 90 negative 60 multiplied with f of 90, the extreme value. This is added up with 120 negative 90 multiplied with f of 120 positive the final value, which is 135. So 135 minus 120 multiplied with f of 135. Now this is important. Now for this step they will give you 1 mark. If you do not write this step, you won't get that particular score. So make that as priority. Now after which you have to subtract 90 minus 60. So 90 minus 60, you can place that value there, and if you were to place that value, this is going to be 30 times f of 90 plus, and this is 30 times f of 120 plus 15 times f of 135. Now f of 90, f of 120, f of 135, this is actually provided in the question. Okay, so what I will do is I will show you, I will place the question, the data on the screen. So this is equal to 30 times f of 90 from the table. I'm going to place it on the screen. This is 0.15 plus this is 30 times f of 120, that's 0.1 positive 15 times 0.05. so you will have to evaluate this. Now if you were to evaluate this, this would approximately give you, you can use this approximation sign of 8.25 gallons. You need to write down the unit. Now after you have written the unit down, it is better you state the conclusion. So hence the amount of gasoline being pumped into the tank, it's not 120, it's 135, for 135 seconds is approximately equal to 8.25 gallons. So if you write down this, you get 1 mark. If you find the value, you get 1 mark. Now this is for your understanding. Okay, now if you write this alone without placing in this Raymond's sum, you will get 0 mark. Okay, so have that in mind. So these steps are important. Of course these 2 steps are for your understanding. but this formula and subsequently the eventual calculation is displayed here. It is better for you. And finally the conclusion. So having mentioned this, let's move on. Now this is an interesting part. Now they are asking us, must there exist a C for the value of C lying between 60 and 120 such that f dash of C is equal to 0? Justify the answer. Now for this, what I wish to state here is the mean value theorem. So this, I am writing the definition of mean value theorem. So I will write this down here. The mean value theorem states that if f is continuous on a closed interval, say a comma b, and differentiable in the open interval a comma b, then there exists a point C. Say I'm going to place in a comma b, it's open interval, such that f dash of C is equal to f of b negative f of a divided by b minus a. Okay, so this is actually the mean value theorem statement. Now we are given f dash of C is equal to 0. So how are we going to write the solution for this particular question? Clearly this is how it goes. Okay, clearly f is differentiable. I'm talking about the f given in the question, and that implies f is continuous. That implies MVT, mean value theorem, is satisfied. So this in turn implies, so there is a C in the open interval 60 comma 120, okay, such that f dash of C is equal to 0. Okay, now we don't have to write it as equal to 0. We can say such that f dash of C is equal to f of b negative f of a divided by b minus a. Now we are going to show this is equal to 0. So this in turn would mean f of 120 negative f of 60 divided by 120 negative 60. Now this value, it's given in the table. That's going to be 0.1 negative 0.1 divided by 60, which is equal to 0. So clearly f dash of C is equal to 0. Now we are asked to justify this. So we have actually given that justification that is required. Now what is the meaning of this? Which means, the meaning I'm giving, which means there is a point C in 60 comma 120 where the flow is steady. Okay, so this is the all important understanding that you will have to know. So that means the rate of change is actually producing a steady flow, and this is a very important vital information for fluid dynamics. So that is the conclusion for this particular question. So if you were to score this, if you were to get a score, it is better that you state, you have a clear understanding of the mean value theorem, and then highlight the point. Because f of t is differentiable, naturally it is continuous. So mean value theorem requires f function to be continuous. So MVT is satisfied, and that in turn means that there is a C in 60 comma 120 such that you are getting a value like this. But apparently when you substitute, you are getting equal to 0. Now this is the requirement, but you can still go a step further. You can just say that the flow is steady, right, because of this particular fact, and that is what fluid dynamics engineers require. Now this is part C. Now it says the rate of flow of gasoline in gallons per second can be modeled with this function. G of t is t over 500 times cos of t over 120 raised to the power of 2. The time is given between 0 to 150. Using this model, we have to find the average rate of flow of gasoline over time interval 0 less than equal to t less than equal to 150. Now show the setup for calculation. Now they are asking us to show the setup for calculation, and only then you will be awarded the score. So simply you give the answer or some set of sequence of numbers and state that to be the answer. You're not going to get anything. So foremost, the average, this is given by this formula, 1 over b negative a integral 0 to 100 or I would say 150 g of t times dt. Now what is this? This is nothing but the average rate of flow. This is the all important setup you need to first display. After you have given this, you will have to, in fact, instead of saying 0 to 150, you can simply say A to B. Okay, A to B. And then using the above formula, you can write the average rate of flow. Using the above formula, for 0, 150, we get, so what do we get? The average rate of flow is equal to 1 over 150 negative 0 times 0 to 150. Now g of t is t over 500 times cos of t over 120. Okay, this is squared times the dt. Okay, so they have placed it in parentheses. You don't have to place that. It's understood. So this is equal to 1 over 150 times 500. That's a constant. Place that. And we got t, right? This t is there. T times cos of t over 120 times the dt. So now we need to integrate this. Now you can actually use your calculator to get the solution. That is fair enough, but I do not have a calculator that has the ability to evaluate this. So what I'm going to do is I'm just going to use some calculus. So I'm going to state t over 120 be equal to u. So from here t is equal to 120 times u. So dt is equal to 120 times the du. So this is equal to 5 into 5, 5 5s are 25, 2 5 ones are 5, 6, 7, 1, 2, 3. Okay, so that is for the constant. Now in place of t, I will substitute 120 times u, and in place of t over 120, I will substitute u. Now this is actually squared there, okay, times in place of dt, I'm going to substitute again 120 times the du. Don't bother about the limits, we will handle the limits within a minute. So this is going to be 120 times 120, and you got u times cos u raised to the power of 2. That's going to be cos u squared times the du. And you have 75000. So you cancel 2 zeros and you get 144 divided by 750, and you have u times cos u squared times du. So you will have to integrate this. What I wish to do is I would like to take, let u squared be equal to some x, so 2 times the du is equal to dx, so u du is equal to dx over 2. So substitute this 750 integral x, I would say u du is dx over 2. So you have a 2 there. I'm going to place the 2 there, and I have a dx here. So this is cos of u squared is x. So you need to integrate cos x dx. Now what is integral cos x dx? You know it's going to be sin x. So now this 2 can divide 144 7 times 2 times. So you have 72 divided by 750. And you integrate cos x, you get sin x. Now what is x? X is u squared reverted. This is going to be sine of u squared. But what is u? U is t over 120. Revert that back. 72750 sine of t over 120. Now this has a square there. Okay, this is squared. Now you place the limits. Now the original limits actually stretched from 0 to 150. So I'm going to place it as 0 to 150. So you substitute the upper limit, you get 72 divided by 750 sine of 150 squared divided by 120 squared minus, you put 0 there, everything is going to go off. So now you need to evaluate this 150. Now 150, let me write that down, 72 divided by 75. This is sine of 150 is what? 15 15s are 225. You have a 0 square there. So 0 0 divided by 120 squared is 144 These two things gets cancelled. So 225 divided by 144. So 225 divided by 144. That is 1.5625. So let me show that here. So this is 72 divided by 750 of sine of 1.5625. Now you calculate the sine of this value. So sine of 1.5625. So what is that? You get 72 divided by 750 times 0.027267 etc. You multiply by 72 and you divide that by 750. So you get 2.617 into 10 to the power of -3. So this is the value you are getting. Now this answer, you can rewrite this answer in this fashion. Probably I will place this. This is approximately 0.002617. Now actually if you were to see here, you see this, after 7 you got 666, I would say 669393, 92 and so on it goes. So what you can do is you can just write that as 617 and then you convert that 7 to 8. So instead of writing it as 617, you write it as 618. Okay, because of the fact the solution is like that. Okay, you got to round that up. So I'm going to write it as 0.002618. Okay, so that would be the average rate of flow. Now this is the exact answer. Now you might be wondering, is it necessary that I should do all of this? Now as I mentioned to you, I do not have that powered calculator. I have just got this simple calculator, right? So all I got is the help of calculus. So let us move on to the next one. Okay, we got this part D. Using the model defined in part C, find the value of g dash of 140. Interpret the meaning of your answer. Okay, so we will have to interpret our answer when we get g dash of 140. I will be finding g dash of t here. So I will be utilizing uv formula. So d of u times v is equal to u times v dash positive v times u dash. So by this formula, this is going to be u into v. So it's t over 500. You need to differentiate this. It's going to be negative sine of t over 120, and you got the square there, times I have to differentiate this t over 120 raised to power of 2. That's going to give me 2 times t divided by 120 times differential of t over 120. That's going to be 1 over 120 plus this quantity cos of t over 120 squared times the differentiation of this. That's going to be 1 over 500. This can be further evaluated by multiplying t into t. That's t squared, negative sign, 2 divides here 60 times. So I have 60 with 120. So 60 with 120. This is going to give me 72. Right? You have a 0 and a 0. So 2 zeros are here. So that is for this evaluation. And I got a 5 here. So 5 times 2 is 10, 1, 35, 36. So 3, 6, 1, 2, 1, 2 and a 1, 2. So all these things have to be placed here. So 3, 6, 1, 2, 1, 2, 1. So many zeros are there. This is multiplied with sine of t squared, t over 120, that's squared. Okay, so all of these things are evaluated already. Positive 1 over 500 times the cos of t over 120 squared. So this is my g dash. What is this g dash of t? Now when t is equal to 140, this is what they want. Okay, so substitute that. So you have negative 140 multiplied with 140 times the sine of 140 times 140, 120 times 120 plus 1 over 500 cos of 140 times 140. Okay, now cancel these zeros, so you would get, of course this is divided by 3, 6, 1, 2, 3, 4, 5. So 1 and a 2, so these 2 zeros goes away. 14 into 14 is 196 divided by 3, 6, 1, 2, 3, 0. So that is there. Now this is sine of 196 divided by 144 plus 1 over 500 cos 196 divided by 144. Okay, now you need to evaluate this. 196 by 144, let me show you that. 196 divided by 144, this is 1.36. so sine of 1.361 we have to calculate, and cos of 1.361 we have to calculate. That has to be multiplied with 196 divided by 3600. Okay, let me utilize this calculator. So sine of 1.361, that is going to give me 0.97807, and that has to be multiplied with negative 196 and divided by 3600. So let me do that. So multiply by 196 and you divide by 3600 and a 0. So what do you get? You get 5.3250 10 to the power of negative 3. So this is one side, plus cos of 1.36. Find out cos of 1.361, and that is giving me 0.20826. that has to be divided by 500. So you divide by 500, you get 4.16521 10 to the power of negative 4. So you need to write them down out of the scientific notation. So this is going to be 0.005325 with a negative sign added with 0.00041652. So we have to add these two things. So let me just subtract from here. I'm going to subtract 0.005325. Okay, so what do I get? I get a value of approximately 0.004908. Now if I were to, with a negative sign, right, now if I were to convert this, right, say from 9 I move on to change this, round this off, so this is going to be negative 0.005. Now the question is, what is this? This is G dash of 140, and we have to interpret this result. That's the most important thing. So the interpretation, inference or interpretation is the rate at which the gasoline is flowing into the tank is decreasing, is a keyword, okay, is decreasing at 0.005 is approximate value, right, gallons per second. Okay, so that is the final conclusion. Welcome students, this is question number 2. Stephen swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Stephen's velocity is modeled by this function where t is measured in seconds and v of t is measured in meters per second. Find all time t in the interval 0 less than t less than 90 at which Stephen changes direction. Give reason for your answer. Okay, so this is part A. Now for Stephen to change direction, this can only happen when v of t is equal to 0. So this is a very important point you will have to state. So this would mean this given v of t 2.38 e raised to the power of negative 0.02 times t sine pi over 56 times t should be equal to 0. Now if AB is equal to 0, this means A is equal to 0 or B is equal to 0. So from here 2.38 e raised to the power of negative 0.02 times t should be equal to 0, or sine pi over 56 times t, this should be equal to 0. Now this cannot be equal to 0 because of the fact that we got an exponential quantity here, but this can be equal to 0. Now we know that sine of 0 is equal to 0, sine of pi is equal to 0, right? We don't have to go further because of the fact that our requirement is between 0 less than t less than 90. Okay, so this one cannot happen because of the fact, again, the interval is 0 greater than, right, the t value is greater than 0 but less than 90. So I drop this and I drop everything that is below sine pi equal to 0. So the only possibility is sine pi is equal to 0. So that would mean, this means pi over 56 times t should be equal to pi. So my pi gets cancelled, so that means t is equal to 56. Now t is equal to 56 is clearly between this range. Okay, so what is the meaning of this? This means at t is equal to 56, that is the point where v of t actually is changing its sign. Okay, so t is equal to 56 is the point where there is a change of direction. So let me make the conclusion. At t is equal to 56, there is a change of direction, and that would mean the velocity will also change its sign. So you can simply state that also. So this means the velocity changes sign. Okay, now just to add an extra layer of protection, you can actually take this clue here at which Stephen changes direction. So they want us to find all t, which we have found in the interval 0 less than t less than 90, at which Stephen is changing his direction. So we can add this final conclusion: Stephen changes his direction when the velocity changes sign. So this is a very important point, and this is the next important point. So you will get 2 points for this. So this is the part B section. It's asking us to find Stephen's acceleration at time t is equal to 60 seconds. Show the setup for your calculations and indicate unit of measure. Is Stephen's or slowing down at time t is equal to 60 seconds? Give reason for your answer. So you are expected to state here, is he speeding up or slowing down? And your choice, whatever be it, should directly correlate to the answer that we have got. So let's see how to do this. Now foremost, we are expected to find Stephen's acceleration at time t is equal to 60 seconds, right? So to get acceleration, what do? We differentiate the velocity. Okay, so this is going to be the acceleration. Now you can directly key in this expression with the differential operator, because you need to get acceleration, into a computing calculator which has the ability to compute the differential value at t is equal to 60 seconds. Okay, but I do not have a computing calculator. So what I am going to do is I am going to show you how to extract the acceleration from the velocity. So foremost, acceleration a of t is nothing but d over dt of v of t. Now this is nothing but d over dt of my velocity is 2.38 e raised to the power of negative 0.02 times t times sine of pi over 56 times t. Now this is a constant, you take that out, the 2.38 goes out, but this has to be differentiated using u times v formula. So d of u times v is equal to u times v dash positive v times u dash. So that's going to be u is e raised to the power of negative 0.02 t times the differential of this, that's cos of pi over 56 times t, times differential of this quantity, that's going to be pi over 56, positive differential of this quantity. So let me write that sine pi over 56 times t there, and when you differentiate e power x is going to be e raised to the power of the same value, 0.02 times t, okay, fair enough, okay, times the differential of negative 0.02 times t. So that is going to be negative 0.02. That completes our differential for b of t. So now what we need to do is we need to evaluate these values. Foremost, what I wish to show you is how to get these things evaluated. Now sine of pi over 56 at t is equal to 60, this is required, right? Now 4 divides here 14 times, 4 divides here 1 time, and 5 times, so 15. So this is going to be sine of 15 pi over 14. Now this can be rewritten as sine of pi positive pi over 14, right? So 180 plus theta. Now this is going to be negative sine of pi over 14. Now let me use my calculator, right? Now watch here. Now when you are utilizing pi, you will have to take the value of pi as 3.14 radian measure. Now this is divided by 14. Fair enough. Now find out the value of sine. So sine of 0.224285. 85, probably you want to place 7, you place 7, you close the parenthesis and find out the value. So how many digits you are taking? 2, 4, 6, 7 digits. And this is giving us a value of 0.22241. Okay, you have a negative sign. Place the negative sign there. Now this is sine of pi over 56 when t is equal to 60. Okay, you have got that off. Now you need to get this. Now cos of pi over 56 times 60. Pi over 56 times 60 is nothing but cos of 15 pi over 14. Now this is going to be cos of pi positive pi over 14. Now what is this going to give us? Negative cos of pi over 14. Now we need to get the value of this. So I'm going to be utilizing the same values, right? So we need to key in this same value because pi over 14 is going to give us the same value. So 0.2242857. So this is the value I will have to place for cos. So this is nothing but this with a negative sign, and we will have to get that value. So let me key in cos. Cos of 0.2242857 equal to, what do we get? We get 0.9749 up until here. So with a negative sign. Okay, we got all these values. Now let me move on to the next page and key in the values. So this is equal to 2.38 e raised to the power of negative 0.02 times 60. This value I have already got, and that is going to be negative 0.97495 multiplied with pi over 56. Now as I mentioned to you, we will be taking pi as 3.14 divided by 56. That is going to give you 0.05607. Now plus this value. What is this? Sine of pi over 56 times 60. That is, you have a negative sign, so it's going to be negative 0.2241, and this is multiplied by e raised to the power of negative 0.02 times 60. So I need to get that value times negative 0.02. Okay, we will evaluate all of this plus this. Now let me get 0.02 times 60. 0.02 times 60. What is that? That's 1.2. So I need to find out e raised to the power of negative 1.2. E raised to the power of negative 1.2. So this is going to give you 0.3011. Probably you just take 4 if you want. Okay, we have got that value. So 2.38. This is 0.301194. Let me multiply this with this. So 0.97495 multiplied with 0.05607. This will give me a value of 0.054665, and then negative and a negative, that's going to be positive. Now this is 0.2241 This is 0.301194 multiplied with 0.0. So this is what we have got. So let me just multiply all of this together. Okay, one more thing, there is a negative sign. I'm going to place the negative sign. If not, our conclusion would hamper. So 0.301194 multiplied with 0.054665. So that's a negative 0.0164648. And this multiplication, what is it? 0.22241 multiplied with 0.301194 multiplied with 0.02. So what do we get? We are having 10 to the power of minus 3. So it's going to be 0.00133398. Okay, I'm just taking this. So it's 1, 2, 3, 10 to the power of minus 3, and you have a plus sign there. So now this, from this, if I were to subtract 0.016468. Okay, I'm getting this value. I have to multiply with this 2.38. So I'm getting negative 0.035998. Okay, now this is the acceleration. Okay, this is my acceleration, right? So we have to give the unit. Now you can give the solution for part B here. You can just say Stephen's acceleration at t is equal to 60 seconds is, you just give 3 decimal places after the digit, after decimal point 3 digits are enough. So that would mean this is going to be negative 0.03, instead of 5 is going to be 6. Okay, meter per second. Okay, you can write it like this, or meter per second squared, right? So this is the solution. Now we need to also find V of 60. Now just substitute t is equal to 60 in the expression for V of t. If you were to do that, this would be giving you a value of negative 0.159512. So if you were to take it for 3 decimal places, this is going to be 3 digits after the decimal, 0.15. This will become 0, so it's going to be 160. Okay, so this is the value for V of t when t is equal to 60, right? Now there is a negative sign, you need to place the negative sign. Now why did I find this value? Because the question wants us to find if Stephen speeding up or slowing down. That's critical, right? Now this is the conclusion. You have to write it like this. Okay, Stephen, since V of t and A of t have the same sign, okay, Stephen is speeding up. I hope you are able to watch this. Speeding up at time t is equal to 60 seconds. Okay, now the reason is this, because B of t and A of t have same signs. The all important conclusion that is required. Students, this is question C. Find the distance between Stephen's position at t is equal to 20 seconds and his position at t is equal to 80 seconds. So they are asking us to find S of t. Now this S of t is obtained if we had to integrate integral 20 to 80 V of t dt. So because of the fact the distance is positive, so this is how the setup that we will have to apply to solve the question. Okay, having given that information, if you have a computing calculator, you can directly apply this function onto your calculator between the limits and get the value. So that would take you probably about 1 minute. Now I'm going to show you the numerical way of integrating. Now this need not be applied, okay, but it will increase your knowledge point, numerical integration, because as you progress you need this particular tool. So I'm going to demonstrate. As also I mentioned to you, I would be just having or utilizing this calculator. Since I've got this calculator, I will be resorting to showing you how to apply numerical integration. Now what I will do is I will apply the Simpson's 1/3 rule. So by Simpson's 1/3 rule, foremost what we need to do is we need to take the function. So v of t is given to be as 2.38 e raised to the power of negative 0.02 times t times sine pi over 56 times t. So this is what is given. So first step. After which what we need to do is we need to select, you can use the word select or choose the number of intervals. Okay, this is the second step. Now for that I would take n is equal to 6. Next step, so let me probably write that down. Step 1 and step 2 and step 3. So step 3 we need to find h. H is b negative a divided by n. My b is the top interval or top value, 18 negative, my a is 20, my n is 6. So this is going to be 60 divided by 6, which would give me 10. Now this is one of the reason I picked 6, because I'm getting a complete value. Now after which you need to apply the Simpson's rule. So Simpson's rule, I'm going to state the Simpson's rule. Integral a to b, say f of t times dt is approximately, the symbol is needed, b minus a. Since it's 1/3 we place the 3 and then we start with the initial value. So that would be represented as f of a naught, and that is followed by 4 times of the odd values. So that will be f of a1 plus f of a3 plus etc. Okay, only odd values here, plus 2 times the even entries. So that would be featured over here. So having given you this, let me just show you how to apply units until you reach 80. So 20, 30, 40, 50, 60, 70, 80. So this is the last entry. You start with a0 and start entering the values a1, a2, a3, a4, a5 and a6. So this is the final entry. Now what you got to do is you will have to substitute all these values. So step 6 would be calculating v of a0. A0 is nothing but in place of t we substitute this value. Now what is v of t? V of t is 2.38 e raised to the power of negative 0.02 t times sine pi of 56 times t. Now v of 20 is 2.38 e raised to the power of negative 0.02 times 20 times sine of pi. I am taking it as 3.14 divided by 56 times 20. So this is the set equations. So after we have got v of 20, we need to find v of 30, v of 40, v of 50, v of 60, v of 70 and v of 80. Now as I mentioned to you, this is a0. Now this will be a1, a2, a3, a4, a5 and this is the last value. So we don't number the last entry, and we just number those entries which are lying in between the initial and the final. So now the Simpson's rule, this is approximately equal to b minus a, that's going to be 10 over 3 times the first entry you place that, followed by 4 times of all the odd entries goes in over here. So this is v of 30 plus v of 50 plus v of 70, followed by the even entries, all of the even entries. Don't touch the last entry, that is not counted here. So only those entries that are featured here. So the even entries are v of 40 plus v of 60, and what do? We conclude by placing the last entry. That's going to be v of 80. So this is the formula setup for Simpson's rule. Now substitute all of this. If you substitute all of this, approximately you are going to be getting a value of 23.38 meters. Now I have adopted the numerical integration technique just to give you an additional knowledge point. Now this answer, as I mentioned to you, can be got within 1 minute of utilizing our scientific calculator. Now this is the last part. They are asking us to find the total distance. So what you need to do is you need to write this setup. Total distance is equal to integral. The initial point is 0, the final point is 90, and we are expected to find modulus of v of t dt. Now this is a very important setup, after which you can apply your scientific calculator and then key in the v of t function between the limits 0 to 90 and get an approximate value. Now the value that you would get would approximately be 62.1642 meters. Now when you are writing the final solution, you can simply state it like this. So total distance that Stephen swam over 0 less than equal to t less than equal to 90 seconds is equal to 62.16. Probably you can add that 4 and make sure to place this meters, the unit. So that would conclude the final answer. Now if you have read the question says that the slope field for the differential equation is given and we are expected to sketch the solution curve through 0,5. Now the context of the problem is you have a bottle of milk. This is a bottle of milk. Now this is taken out of the refrigerator. So definitely the temperature of the milk is going to be rising. We are given this graph. We are expected to show how the temperature is rising. Now this is modeled out after a differential equation. The graph is drawn t versus m of t. Now t is the time. Now as the time is increasing, the temperature of the milk, which is given as m of t, this will also be increasing. But after a certain point, the temperature will hit the plateau. In other words, it will become steady. So that line is given, but we do not know at what time the temperature of the milk will become steady. But definitely at one particular point, the temperature of the milk will become steady. So this to give you the context. Now we have to depict that by drawing the line through 0,5. So what you need to do is you need to start at the point 5, because we take 5 to be as the temperature of the milk, and then we need to draw this graph like this. That's it. Now there is an asymptote there, because this is the point where the steadiness is achieved and the temperature of the milk will gradually move towards that point. So as I mentioned to you, it will gradually move towards that point. Now this is part B. Use the tangent line to graph m at t is equal to 0 to approximate m of 2. So they want us to find the m of 2 from this information. When the value of m is given, we know the value of m at t is equal to 0. So that is got. They are asking us to find m of 2. That means that t is equal to 2 means we need to extract this. Now this is the equation of the tangent line. Now for a point, say a0 comma f of a0, the tangent line is given as y is equal to, say I'm going to be writing the tangent line for this coordinate. So this is going to be f of a0 positive f dash of a0 multiplied with, now since we are dealing with t, I'm going to be utilizing t. So t negative point a0. So this is going to be my equation. Now what is this A naught? Now this A naught has been given to us from the graph. If you were to see the graph at t is equal to 0, we have a value of m of t to be as 5 units. Utilize these two information over here. I'm going to write this as for 0, 5. So that is going to be my A naught and my f of A naught. So we have, what do we have? Y to be equal to f of A naught, that is f of 0. F of 0 is given to be as 5. So if you were to see the graph, it's clearly given in the graph. So this point is 0, this is my t, and this is my m of t. However, this is the point of steadiness. Now at t is equal to 0, this point is 0, we are given this point and the graph is actually hitting like this. It's an asymptote, so just an approximate figure, there is no touch there. So at this point we know the value, so that's exactly what I'm placing here. So f of A naught is going to be my f of 0 positive f dash of 0 times t minus 0. So this is the setup. So therefore y is going to be equal to f of 0 is 5 units plus, now we need to get this f dash. Now what is this f dash? Where are we going to get this f dash? Let me show you this f dash being present here. F dash is nothing but dm over dt. Now dm over dt is, or I would say this is dm over dt, 1 over 4 of 40 negative m. So let me write that dm over dt. Now we need to get this point at A naught. A naught is going to be my t is equal to 0, at t is equal to 0. So what is this? So this is equal to 1 over 4 of 40 negative. We are taking m at t is equal to 0. So let me just make it a little bit more clear. So 1 over 4 of m of 0 is given to be as 5. So this is going to be 35 over 4. Now take this 35 over 4 and substitute there. 35 over 4 of t negative A naught is 0. We don't have to take that. So you place this t. So this is the system. We have set up the system for calculation. Now what are they asking us? They are asking us find m of 2. So this will give us m of 2 at t is equal to 2. So therefore m of 2 is what? At t is equal to 2 is equal to 5 positive 35 over 4 at t is equal to 2. So this is going to be 5 positive, 2 divides here 2 times, so this is 35 over 2. Now 2 divides here 1 time, you have 15 there, 7 and then 5, and then this is going to be 22.5. So that is going to be the temperature. So this is the final solution for this question. However, this question can be done in 2 steps, but I want to explain the intricate insights. That's the reason I've taken so many steps. So you can just wrap this up. So I'm saying 22.5 Celsius, right? So this is my m of 2, and then you can box it. So that will be the final wrap. Now this is part C. We are expected to we expected to write an expression for d squared m over dt squared in terms of m, and then we have to use d squared m over dt squared to determine whether the approximation obtained at part B, so this value that we got in part B, is it an underestimate or an overestimate. Okay, it's a simple question. So foremost what we need to do is we need to get d squared m over dt squared. So we know that d m over dt is 1 over 4 of 40 negative m. So therefore d over dt of dm over dt is equal to d over dt of 1 over 4 of 40 negative m, which can be rewritten as 40 over 4 negative m over 4 this has to be differentiated. Now this is equal to d over dt of 4 divides here 10 times, so you have to differentiate 10 negative m over 4, which is d over dt of 10 negative d over dt of m over 4. This will give you 0. This will give you 1 over 4 times dm over dt. But dm over dt is this. Substitute that over here. So this is equal to negative 1 over 4 of 1 over 4 times 40 negative m, which is negative 1 over 16 of 40 negative m. Now this is my d squared m over dt squared. Okay, fair enough. Probably we can place this in a box. So that is the solution for the first part. Now the second part, they are asking us to find out if it is an underestimate or overestimate. Now let me show you how to judge an estimate is under or over using the tangent line. Now imagine you have a curve like this, a U-shaped curve going up. Now if you have the tangent lines like this, this is called as an underestimate. Okay. On the other end, if you have a curve like this and you have tangents line like this, this is called as an overestimate. So this is case 1 and this is case 2. Now the question is, you know there is a tangent, but we need to judge what is the shape of the curve. How do we judge that? We will have to judge it from d squared m over dt squared. Now you see the sign is negative, but we will have to find out the values, all values that m is taking. Now if you were to go to the question says that the value of m of t is always less than 40. This is given in the question. So what does it mean? M will never be greater than 40. So m will always be less than 40. So that would mean this will give us a positive value. Now this quantity that we get has to be multiplied by the quantity or the sign that is present here. Now this is positive. Positive times negative will give us a negative. Right? So that means d squared m over dt squared is negative for the values of m of t given here. So we need to specify that. So this is the reason. They are asking us to give us the reason. So what is the reason? Given that m of t is less than 40. Okay. So this means d squared m over dt squared will always be less than 0. So why is it less than 0? I have explained to you that over here. So this means the curve that we are actually getting can easily be judged here. So I'm going to write that down. So this means the graph is concave down. Okay, so we have a concave down and the tangents would be drawn like this. That's the only way we can draw. So this in turn implies the estimate obtained at B is an over estimate. So that would be the complete reason for this question. Now this is part D, use separation of variables to find an expression for m of t, the particular solution to the differential equation. Now we have been asked to obtain this, and this is the differential equation given with the initial condition at t is equal to 0, the value that m takes is 5. So let me do that. So this is given that dm over dt is equal to 1 over 4 of 40 negative m. So we are required to obtain the particular solution. So what do? I'll use variable separable technique. So variable separable technique is used. So you have dm there. Now what I would do is I would bring this 40 negative m down and I'll take this dt over there. So it's going to be dt is 1 over 4. So this is what we have got. Now I'm going to integrate both sides. You can state that integrating both sides we get. So this is going to give me ln modulus of 40 negative m, but there will be a negative sign because of the sign of negativity being present before m. Now this is going to give me, this is actually, what is this? This is 1 over 4 times integral dt, which is nothing but 1 over 4 times t, right? So place that 1 over 4 times t. Positive arbitrary constant c. Now we need to get this c value. From this setup, what we have to do is we will have to find c. So that's exactly what I'm going to do. For t is equal to 0, what is given? The value of m is 5. So if we were to substitute that, this is 1 over 4 of 0 positive c. This is ln modulus 40 negative 5, the negative sign. This is going to give me negative ln modulus of 40 negative 5 is 35 is equal to c. Therefore c is equal to negative ln 35. Now if I were to take this as 2, therefore 2 can be rewritten as negative ln modulus 40 negative m is equal to 1 over 4 times t negative ln 35. Now we know what is given. Given that m of t is always less than 40. Now this is given in the question. So this would mean 40 negative m will always be positive. So I'm dropping the modulus. So that's the understanding. So I can write that. This means modulus of 40 negative m is equal to 40 negative m. So if you were to take this as 3, therefore 3 can be rewritten as negative ln of 40 negative m is equal to 1 over 4 times t negative ln 35. We need to get the solution. We need to obtain m. So how are we going to do that? What I'm going to do is I'm going to get rid of this negative sign. I'm going to take this as 4. Multiply 4 with negative 1. So that would give me ln of 40 negative m is equal to negative 1 over 4 times t positive ln 35. Now move this over here. So this is ln 40 negative m negative ln 35 is negative 1 over 4 times t. Now we know that ln of a negative ln of b is equal to ln of a over b. So this is equal to ln of 40 negative m divided by 35 is equal to negative 1 over 4 times t. We also know that ln a to the base y is equal to some b. Therefore a is equal to y raised to the power of b. Now in this case I have taken it as y, but it's going to be, y is going to be equal to e here. So just to avoid some confusion, I'll take it as log, log. So also ln a is equal to say some b. A is equal to e raised to the power of b. So just to avoid any confusion, I have rewritten the formula for e. So this is going to be 40 negative m divided by 35 is equal to e raised to the power of negative 1 over 4 times t. You cross multiply this, you get 40 negative m is equal to 35 times e raised to the power of negative 1 over 4 times t. You need m. Now what we have to do is we will have to get the value of m. You can push this to the other end. You can move this to the other end. So you get negative m is equal to 35 times e raised to the power of negative 1 over 4 times t. This is negative 40. But since I need m, I'm going to multiply this by negative 1. You can state it here, multiplying both sides by negative 1 we get. So what do we get when you multiply? You get m is equal to this, I'm writing this as first 40 negative 35 times e raised to the power of negative 1 over 4 times t. And that is a good place for us to block the result. So that's the end of this particular question. We move to the next one. Now this is question 4. We are expected to find if f has a relative minimum or a relative maximum or neither at x is equal to 6. So this is the point we are looking for. Now this is the graph of f dash. To answer this question, what we have to do is we have to find the signs of this function f dash. Now go to the graph, and you can clearly see that the graph is actually segmented in regions of -1 and above, between -1 and 2 and 2 and 6 and 6 and above. So just go and check at these orientations of the line. If the line is above the x-axis, then the sign of the function is positive. If it is below the x-axis, then the sign is negative. So just to place the signs. Over here the graph is going above the x-axis, so on this side it's going to be positive. It is coming below the x-axis, so between -1 and 2 it's going to be negative, and the next segment 2 and 6 it is going above, so it's positive here, and 6 and beyond it is going above, so it's positive here. Now the requirement is we need to find if the function f has a relative minimum or relative maximum or neither at x is equal to 6. So see, at this particular point x is equal to 6, if there is a sign change. Now clearly you see that there is a positive on the left hand side and there is a positive also on the right hand side. So there isn't any sign change. So clearly you can state that reason. Since f dash has no sign change at x is equal to 6, this will imply that the function f has neither a relative max or a relative min at the point x is equal to 6. So that is the conclusion for this particular question. We move on to the next one. Now this is the next question on what open intervals, if any, in the graph the function f, or I would say we are required to find the open interval where f is concave down, and we are asked to give the reasons. So the question is on what open intervals, if any, is the graph of f concave down. Okay, now this is the graph we are talking about. Okay, now this is the graph for f dash, but they are asking us to give the graph of the original function f. Now let me write the reason here. For f to be concave, f dash should be less than 0, and for f dash to be less than 0, f dash should be less than 0. So this would mean we would have to find all intervals where f dash is decreasing. So that is the idea. So go to the graph and find out where all the function, or I would say f dash, is decreasing. Okay, this is required. So over here from -2 it is going down. Okay, it is going down all the way to this point 0. Okay, probably you can just give it, you don't have to draw this, I am just showing you. So it's decreasing, so between -2 to 0. So we need to give the interval, hence f dash is decreasing at or between -2 to 0, and now here it is increasing, so we cannot take this particular point. Okay, but we have to check where again it is decreasing. Now this particular point is actually 4 units. Okay, so you see over here the function is actually decreasing, it's coming down to 6. So between 4 and 6 it is decreasing, and then again it increases, and interval 4 and 6. So this in turn means f is concave, okay, down, at negative 2 comma 0 and 4 comma 6. So that would be the answer. So I can just add a all important word, concave down. So have to be concave down. Okay, that is more explanatory. So let's move on. Now this is part C. We are expected to find the value of limit extending to 2 6 times f of x negative 3x divided by x squared negative 5x positive 6, or show that it does not exist. Now foremost, let me show you the graph. Now this is the graph of f dash. In other words, from this figure we know that the graph of f dash exists. So this is a solution. Given that the graph of f dash exists, this means f is differentiable. That's the understanding of that. When f is differentiable, this means f is continuous. Now this in turn would mean the limit of f exists. That's the first point that you will have to mention, because if the limit of f does not exist, there is no point in proceeding in evaluating this. So we will have to suitably justify for the other case. But in this case, the justification is we would be heading to find the limit. So consider limit extending to 2 6 times f of x negative 3 times x divided by x squared negative 5x positive 6. Now applying limits, you can write this sentence. Applying limits, we get. So what do we get? When you apply limits, x takes the value 2. So this is going to be 6 times f of 2 negative 3 times 2 divided by 2 squared negative 5 times 2 positive 6. Now we need to get the value of f of 2. So let me evaluate this. So this is going to be 6 times f of 2 negative 6 divided by 4 negative 10 positive 6, and we are given that f of 2 is equal to 1. It's in the question. So this would mean 6 times of 1 negative 6 divided by 10 negative 10 is 0 by 0 form. So that would mean I would apply L'Hopital rule. Applying L'Hopital rule means what? Differentiating the numerator and then differentiating the denominator. So that would mean differentiation of the numerator. So it's going to be 6 times f dash of x negative 3 divided by 2 times x negative 5. This is the differential for the denominator. We have to apply the limit. So I'm going to state it like this. Applying limits for what value? X is equal to 2. Now go back to the graph and find what is f dash of 2. We need to find f dash of 2 here. So it's going to be 6 f dash of 2. I hope you're able to see it. Negative 3 divided by 2 2s are 4 negative 5. Okay, let me place it over here. F dash of 2. What is this? Is the graph for f dash. Now f dash of 2 is what? 0. So substitute that value. So 6 times of 0 negative 3 divided by 4 negative 5. That's going to give you negative 1. Now this is going to give you negative 3 divided by negative 1, which is equal to 3. So that is the value of this limit. You can simply state that. So therefore limit extending to 2 of 6 times of f of x negative 3x divided by x squared negative 5x positive 6 exists, and the value is 3. So that is the solution for this question. So let's move on. Okay, this is part D. We are expected to find the absolute minimum value of f on the closed interval negative 2 to 8. Now I've drawn the graph. So this point is going to be my 8 and this is negative 2. Now as I mentioned to you in the first part of the question, find out the points where the graph is actually going above the x-axis. Now if you were to do that, let me draw the number line. I'm going to place in the points. This is negative 2, negative 1, 0, and then 2, and then we got 6 and 8. Okay, you got the point 6 and then it goes on. So this is the line. Now between -2 to -1, the graph is going up, so it's positive. Between -1 and 2, the graph is going down, so this sign is going to be negative. And between 2 and 6, the graph is going up, so it's going to be positive there. Now this is an important point, -2 to 1. Why do I say it is an important point? Because at -1, the graph is cutting the x-axis. So this point is a cut, and similarly there is a cut here on the x-axis. So this point is another cut. Go to the left, see the sign. Go to the right, see the sign. If you see a change of sign, then clearly you can state without the element of ambiguity, there is definitely going to be a relative value. Now whether it is relative minimum or relative maximum, that has to be judged. So let me write that down here. F dash changes from positive to negative, so that would mean there is a relative maximum. This implies F as a relative maximum. Where is the intersection taking place? At x is equal to -1. So this is the first point. Okay, let me name it like that. Now go to the next point. Next point is 2. Now look at the left, look at the right. So what is the sign you see? I see a negative, I see a positive on the right. So there is definitely an activity going on there. Also, F dash changes from negative to positive at x is equal to -1. So just for clarity, now in this case from negative to positive at x is equal to 2. So this would mean the original function f has a relative min at x is equal to 2. So this is the first point of inference that we have got. But the question says find the absolute minimum value. So between -2 to 8, we will have to look at the absolute minimum, where exactly the function gets. So objective, f has to obtain the absolute min value between -2 and 8. So this is the requirement. Now how are we going to get that? That is the objective of this question. So what do we know? We know that f of 2 is given to be as 1. This value is already given. So now what I'm going to do, we will find f of -2. So I want to get this value, f of -2. Let me find that value. How do we do that? Consider integral -2 to 2 f dash of x times dx. Now this is the derivative, this is the integral. So the outcome is going to be the original f of x from -2 to 2. Now let me go to the next. This is equal to f of 2 negative f of -2. So this is got. On the left, what do I have? -2 to 2 f dash of x times dx. Now I am trying to get the value of f of -2. So f of -2 is equal to f of 2. Move this to the other side. Negative integral -2 to 2 f dash of x times dx. So this is the value that we have got. We know that f of 2 is 1. That's given in the question, but we will have to obtain this. So what is this? This is actually nothing but area under the curve. So let me use this graph. Okay, area under the curve. Now -2 to 2. This is -2. This point is +2. So we have to find the area of this triangle. Next we will have to find the area of this triangle. what is this area of a triangle? This is the height, this is the base, this is the height. The height is 2 units here, the base is 1 unit here, and area is equal to base times height divided by 2. So 2 multiplied by 1 divided by 2 is equal to 1 square units. I hope you are able to see that. Now come over here. So what is this area? This area is again half times the base. What is the base? So this is 2 units and this is 1 unit. So the base is 3 units and the height is what? 2 units. So this is 3 units, but this is on the negative part of the axis. So this will take a negative 3 and this will take a positive 1. So the total area is 1 added up with negative 3 is equal to negative 2. So take that value, negative 2, and place it over here. So this is equal to 1, negative of negative 2, that is going to give me 1 positive 2 is equal to 3. So f of negative 2 value is equal to 3. So you put a box. Okay, now let's move on. So now we need to get the value of f of 8. So for that we would consider integral 2 to 8 f dash of x dx, which is going to be f dash or we say f of x, limits are 2 to 8, which is equal to f of 8 negative f of 2. On the left we have 2 to 8 f dash of x times dx. We need this, so therefore f of 8 is equal to integral 2 to 8 f dash of x dx positive f of 2. Now what is f dash, or I would say integral 2 to 8 f dash of x dx? This is nothing but area under the curve. Okay, I'm going to show you that. So 2 to 8, go back to the figure. Now this figure can be divided into 2 parts. Now this part is a triangle. You need some visualization, so I need to get this area, and this part is there is a rectangle there. So what I'm going to do is I will find out. Okay, when I come here I'll show you how to do that. So this area of this is what? Area of the dotted triangle is equal to half times my base is 2 units, my height is going to be 2 units, so this is going to be 2 units. So this is positive, this is also positive. Now over here what you have to do is you will have to take the area of the rectangle, because you are actually looking to find this region, you wanted to find this area. So for that you have to take the area of the rectangle. So let me write that down here. So say region 4, area of R4 is equal to area of rectangle minus area of the semicircle. So area of the rectangle, what is that? So you have a base here and you got the height. So the height is 2 units, the base is 4 units. Base is 4 units and the height 2 units minus area of the semicircle. Area of the circle is pi r squared. Pi into radius. What is the radius? Radius is 4 to 8. So that's going to be 2 units here. So pi r squared is going to be 2 squared divided by 2. So this is going to be 8 negative 2 pi. This is what you have got. Now from here you need to add this region. So plus, what is this area? We have already got this area. So this is going to be 2 units. Base is 2 and height is 2 units is area. So the total area, when I talk about total area, I'm talking about 2 to 8 f dash of x dx. So as I mentioned to you, this region is 2 units and this region, the other region, this region is 8 negative 2 pi. So that's going to be 10 negative 2 pi. But we need f of 8, right? So f of 8 is this formula. So therefore f of 8 is equal to integral 2 to 8 f dash of x dx positive f of 2. This is 10 negative 2 pi positive 1. This is going to be 11 negative 2 pi. Now this is my f of 8. Now clearly, if you were to go back, you check the values. We have got f of negative 2 as 3 units. That's exactly what we got here. And f of 2 is what? 2 units, 1 unit. And f of 2 is equal to 1 unit. So which is the absolute minimum? So this means f of 2 is equal to 1 is the absolute minimum. Okay, that's the conclusion. And probably you can write here, and the minimum value is equal to 1. Okay. Now this is question number 5. It states that h be a function defined as h of x being equal to f of g of x. Find h dash of 7. Now we got to use this table. So this table will be utilized in this question. So foremost, let me differentiate this given h of x. So I'm going to state that differentiating with respect to x, we get, so what do we get? H dash of x is equal to, differential of this entire quantity is f dash of g of x. Next you differentiate g of x, that's g dash of x. Now at x is equal to 7, h dash of 7 is equal to f dash of g of 7 times g dash of 7. We know that, what do we know? G of 7 is equal to, go to the table, find g of 7, that's 0. And g dash of 7, what is the g dash of 7? G dash of 7 is what? 8. So hence you can use this word, hence we now have h dash of 7 is equal to f dash of g of 7 is 0, g dash of 7 is 8. Also we know that f dash of 0 is equal to f dash of 0. F dash of 0 is what? 3 over 2. So you can state that hence we now have h dash of 7 is equal to 3 over 2 multiplied with 8 is equal to 12. So therefore h dash of 7 is equal to 12. You box the result. So that will give you the score that you need. So let's move on to the next question. Now this is the next question. Let k be a differentiable function such that k dash of x is given as f of x raised to the power of 2 times g of x. We are asked to find is the graph of k concave up or concave down at the point x is equal to 4, and we are expected to give reason. Now foremost, to find if the graph is concave up or concave down, we need to get k double dash of x. So let me do that. So differentiate with respect to x, we get, so k double dash of x is equal to, I'm going to use uv formula. So it's going to be u times v dash positive v times u dash. So f of x whole square differentiating g, I get g dash of x positive g of x, differentiating this will give me 2 times f of x times f dash of x. Now at x is equal to 4, we need to get that. So substitute x is equal to 4. So this means k double dash of 4 is equal to f of 4 raised to the power of 2 g dash of 4 g of 4, write 2 there, times f of 4 times f dash of 4. Okay, now f of 4 is 4, so it's 4 squared, and then g dash of 4, g dash of 4 is 2 plus 2 times g of 4, g of 4 is negative 3, f of 4 is 4, f dash of 4 is 3, So 16 to 32, 4 3s are 12, 12 and 12 times 3 is 36, multiplied by 2, 12 1 72, so negative 72, so you get negative 40 less than 0. So what is the implication? Since k double dash of x at x is equal to 4 is less than 0, this means, what is the meaning of it? The graph of k is concave down at x is equal to 4, and you can add one more line, because k double dash of 4 is less than or equal to 0, and okay, so this is the solution for this question. So we move on. This is question C. Let m be a function defined by m of x is equal to 5 times x cubed, positive integral 0 to x f dash of t dt. Find m of 2. Okay, so let me do that question. Now given, what is given? Given m of x is equal to 5 times x cubed, positive integral 0 to x f dash of t dt. Now at x is equal to 2, we have, what do we have? M of 2 is equal to 5 times 2 cubed, positive 0 to 2 f dash of t times dt. This is 8 times 5 is 40, positive integral, you are integrating f dash of t, so you would get f of t, limits are 0 to 2, so this is equal to 40 positive upper limit minus lower limit. Now this is equal to 40 positive. Now find out the values. Go to the table. F of 2 is 7, f of 0 is 10. Okay, so this is 40 positive, 7 minus 10 negative 3, which is equal to 37. So this is my m of 2 value. Okay, so this is the working and this is the final answer. So you need to give all of these steps to get the entire score. Now this is part D. Is the function m defined in part C, is it increasing, decreasing, or neither at x is equal to 2? Justify your answer. Now this is the function that has been given to us in part C. So therefore if you were to find the derivative, this will give you 15x squared. If you differentiate this, you would get f dash of x based on the concepts that we have studied earlier. Now at x is equal to 2, this is going to be giving me 15 of 2 squared positive f dash of 2. Now this is 2 squared is 4, 4 times 15 is 60, positive f dash of 2. Go back to the table, f dash of 2 is negative 8. So this is going to give you f of 2. So therefore m dash of 2 is equal to 52, which is greater than 0. So what is the conclusion? The conclusion is the graph of m is increasing. How do you say it's increasing? Increasing at x is equal to 2. So the point is, how do you say? Because you can state it, because m dash of 2 is greater than 0. I hope you got that. So the graph of m is increasing at x is equal to 2 because m dash of 2 is greater than 0. So that concludes the solution to question D. So we move on to the last one. So this is the last question. Consider the curve given by the equation 6xy is equal to 2 positive y cube. We are expected to show that dy over dx is equal to 2y divided by y squared negative 2x. So let me start off like this. Consider 6xy is equal to 2 positive y cubed. Now differentiating with respect to x, we get, so what do we get? This is UV formula. So 6 times x into differential of y dy over dx plus y into differential of x, that's 1. Differentiation of 2 will give me 0. Positive differentiation of y cubed is 3 times y squared times dy over dx. So what I'm going to do, I'm going to retain 3y squared dy over dx on this side, and I'm going to move this to the other side. So this is nothing but negative 6 times x dy over dx, and I will retain 6y on the left. So I'm just distributing it and retaining it. So now you take dy over dx out, so you get 3y squared negative 6 times x. Now on the left you got 6y, push everything down, and this is going to be 6y divided by 3 times y squared negative 6x is equal to dy over dx. So therefore dy over dx is equal to 6y divided by, take 3 out, you get y squared negative 2 times x, 3 will divide here 2 times. So this means dy over dx is equal to 2y divided by y squared negative 2x, which is equal to right hand side, or you can say hence the result is proved. Okay, so that's the solution for this particular question. So you need to give all these steps. So let's move on to the next one. Okay, so this is the next question, question B. Find the coordinates of a point on the curve at which the line tangent to the curve is horizontal, or explain why no such point exists. So this is the first requirement. For the line tangent to the curve to be horizontal, it is necessary that dy over dx is equal to 0. This implies 2 times y, because we got this value, right? 2 times y over y squared negative 2x is equal to 0. This implies 2y, you cross multiply, you get 0. So this means y is equal to 0. Now they are asking us to find the point. So given the curve as 6xy is equal to 2 times, or I would say 6xy is equal to 2 positive y cubed, we put y is equal to 0. So this would give us 6x of 0 is equal to 2 positive of 0 cubed. This will be 0. This will be 2 positive 0. This means 0 is equal to 2, which is not possible, a contradiction, and then you write not possible. Now it is not enough, or I would say after you have written all of this, you need to give the conclusion. So you can state here, so therefore there is no point on the curve at which the line tangent to the curve is horizontal. You need to state that. So that completes the solution for this question. So we move on. Okay, so this is part C. Find the coordinates of a point on the curve at which the line tangent to the curve is vertical, or explain why no such points exist. Now we are actually looking for the vertical tangent, right? So for that we want the denominator to hit undefined. So let me give the solution. So we know that dy over dx is equal to 2 times y divided by y squared negative 2x. Okay, so for the vertical, in other words, for the line tangent to the curve to be vertical, the necessary condition is y squared negative 2x should be equal to 0. So which means y squared is equal to 2x. From here I want to extract x, so x is equal to y squared over 2. Now we are given the curve as 6xy is equal to 2 positive y cubed. So substitute the value of x. So this is 6 times y squared over 2 times y is equal to 2 positive y cubed. This is 3 times y cubed is equal to 2 positive y cubed. Move this to the other side, you get 3y cubed negative y cubed is equal to 2. So 2y cubed is equal to 2. I'm working out here. So y cubed is equal to 1. So y is equal to third root of 1, which means y is equal to 1. Now when I'm working out here, when y is equal to 1, you take this as 2. So therefore 2 becomes 6 times x of 1 is equal to 2 positive 1 raised to the power of 3. This will add up, will give you 3. This is 6x. So x is equal to 3 over 6. X is equal to 1 over 2. So we have a vertical tangent located at this point. So this is the conclusion. So you need to write the conclusion like this: the tangent line or line tangent to the curve is vertical at the point x value is what? 1/2. Y value is what? 1. So that is the conclusion, and this is the complete working for this question. Okay, we move on. Okay, so this is the last question. A particle is moving along the curve. At the instant when the particle is at the point 1/2, -2, its horizontal position is increasing at the rate of dx/dt is equal to 2/3 units per sec. What is the value of dy/dt? The rate of change of the particle's vertical position at that instant. So we are expected to find this. Now this is the solution. So what are we given? We are given the equation of the curve 6xy is equal to 2 positive y cubed. So now what I'm going to do, I'm going to be differentiating implicitly with respect to t. So 6 times of u into v. So x, when I say u into v, I'm utilizing this formula. D of uv is equal to u times v dash plus v times u dash. So x times differential of y, that's dy/dt, positive y times differential of x, that's dx/dt, is equal to 0 positive 3 times y squared times dy/dt. Now this is going to be 6x dy/dt positive 6y dx/dt. dx/dt is this 2/3. So 2/3 is equal to 3 times y squared dy/dt. So extract dy/dt. So for that, what I wish to do is I would like to move this to the other side. Now 3 divides 6 2 times, so 2 squared is 4 times y is equal to, I'm going to take dy/dt out, so that would give me 3 times y squared negative 6x. Now therefore dy/dt is 4 times y divided by 3 times y squared negative 6x. So this is what we have got. Now the points are given here, 1/2, -2. So I'm going to utilize this part. At x is equal to 1/2 and y is equal to -2. So dy/dt is equal to 4 times of -2 divided by 3 times of -2 squared negative 6 times of 1/2. Now this is going to give me -8. This is -2 squared is 4, 12, and this is 3. So -8 divided by 9. So this is what we are getting. So you make the conclusion. I'm writing a conclusion here. So therefore the rate of change of the particle's vertical position is -8/9 units per second. Okay, you got to state that. So that is the end of this particular question. Thank you everybody. Please like, share and subscribe until we meet again.